Good morning, everybody. Since Mrs. Seng will come tomorrow evening, I'll give the presentation instead. This is my topic, Development and Verification of China Railway BIM Standard. I will focus on the following three aspects: overview of the development of China Railway, development of China Railway BIM Standard, and verification. First, the overview of the development of China Railway. By the end of 2016, China's railway in operation reached 124,000 kilometers, including the double-track railway, 64,000 kilometers, the electrified railway, 74,700 kilometers, and the high-speed railway, 21,700 kilometers. By 2025, the scale of the railway network will reach 175,000 kilometers, including 38,000 kilometers high-speed railway. Second, development of China Railway BIM Standard. Railway is an important traffic infrastructure. Its informatization is an important carrier and means to realize the intelligent railway and railway modernization. China Railway Corporation introduced the BIM technology in 2013 for the life cycle management of railway. However, the existing BIM standards do not cover the railway industry, so the research on railway BIM standard needs to be carried out. In December 2013, the China Railway Corporation and other 7 governing units established the Chinese Railway BIM Alliance. As the first BIM technology self-regulatory organization, CRBIM takes the responsibility to promote railway BIM technology progress in China, aimed at building a public service platform for BIM technology, overall planning and policy recommendations, standards development, application technology research, research training, technical services and consulting, international exchanges, and cooperation. CRBIM currently contains 72 members, has a profound impact both at home and abroad. We have 11 national laboratories, 17 post-doctoral workstations, 8 enterprise-level BIM research bases, 2 national BIM qualification training centers, including the National Engineering Laboratory for high-speed railway system testing. CRBIM gathered the top scientific research, survey, design, construction, management, operation, and maintenance, manufacturing enterprises, and related key universities in China, has the capability of production, learning, research, and utilization, and whole industry chain integration innovation advantages. Based on the principles and methodology of CRBIMs and BIMs, we construct the framework of China Railway BIM Standard System. Technical standards are basic standards. It is the basis for formulating implementation standards and deeper application of BIM, which can be used to guide and standardize the development of railway BIM software. Implementation standards are the usage specification of technical standards. Enterprises can standardize their own working procedures, management models, resource construction, environmental configuration, and deliverables. Railway Data Model Standard Part 1 and Classification Coding Standard were promulgated at 2014. Railway Data Model Standard Part 2 was promulgated at 2016. And a series of delivery standards were promulgated at September of 2017. Railway data model include compilation scope, application scope, and content. Compilation scope currently covers 12 domains in railway engineering, including alignment, track, subgrade, bridge, tunnel, station, drainage, geology, communications, signaling, power transformation. Application scope: railway engineering BIM implementation standard formulation, BIM software development, and BIM application research. And the content include general rules, terminology, and multiple professional domain models. With the method of increasing entity type and attribute set, the data storage standard of railway engineering information model is realized based on IFC. We combine static extension and dynamic extension together. Static extension refers to the definition of the entity in railway engineering professional fields on the basis of IFC4 model, followed by the inheritance principle of object-oriented thinking. Dynamic extension means that the IFC model is not changed on the basis of the existing IFC entities, and specific types of entities are identified by citing railway BIM classification and coding standard. In resource layer, we add the definition of alignment to the geometry resource. In core layer, we extend IFC alignment type to represent the alignment of railway. In interop layer, we add the definition of railway engineering sharing mode, including public type, public space structure, public parts, and public attribute set. In domain layer, we extend 8 professional areas, including alignment, track, subgrade, bridge, tunnel, station, drainage, and geology. This is a special structure of railway engineering. The railway project may include one or more railway or railway terminal. The railway can contain one or more alignment, track, subgrade, bridge, tunnel, railway station, building. Railway terminal can also contain a series of railway and a railway station. And this is the railway entity inheritance relationship of IFC. The white blanks represent the existing content of IFC standard, and the others represent the new extension of the railway IFC. It is divided into several branches, including special structure units, components parts, line, center line, and system. This is the concept composition of railway IFC standards. Special structure element, assembly, physical element, component, system, and property set. Internationalization is a basic principle in the study of Chinese Railway BIM standard. Since 2015, the China Railway BIM Alliance has participated in the buildingSMART Summit 2 times a year. Approved by buildingSMART, the English version of the data storage standard for railway engineering information mode was published in 2016 as an open standard. And the last one, verification of China Railway BIM standard. China Railway Corporation started 16 pilot BIM projects, including 3 complete sections, 3 bridges, 3 tunnels, 1 subgrade section, 3 stations, 2 projects for electric power, traction power supply, communications, and signaling railway engineering. This is the application of tunnel, geology, bridge, station, and a complete section. And this is the application of subgrade section, electric power, traction power supply, communications, and signaling railway engineering act. In order to promote the application of BIM technology in China Railway, CRDC developed a software package to implement railway IFC standards in that order system, new type for design management, and a new attribute set for project quantity calculation are added. 195 types and 349 attribute sets are contained in software package. The highlighted part of the picture is a simply supplied gird. The predefined type of IFC bridge part is gird, which has a complete set of attributes and can be matched with the IFD code. The highlight part is a railway pier. The predefined type of IFC bridge part is pier and also has a complete set of attributes and can be matched with the IFD code. In the 2017 Barcelona's Spring Standard Summit, CRBIM introduced the IFC rail project proposal and the verification work of tunnel and alignment standard, signed a memorandum of understanding on the establishment of the IFC rail with buildingSMART, Germany, France, Sweden, the Austria Railway Company, Finland, and Sweden Transport Bureau. Under the organization of buildingSMART, CRBIM is responsible for the compilation of IFC rail international standard and participates in the preparation of other standards involved in infrastructure, such as IFC common schema, IFC bridge, IFC alignment, IFC tunnel, IFC load. 2 online meetings were held to introduce the spec standard of China Railway. And we also organized to complete the IFC rail project proposal. These are details. In May 11, we introduced the framework of IFC rail, application of IFC rail bridge and track. In July 18, we introduced and discussed the IFC rail standards part 2. In July 18, September 5, September 28, we discussed the IFC rail project proposal and the project budgets. Together with all partners to complete the project proposal, project package, and study scope. We participated in IFC bridge project discussion 8 times. The bridge types and the bridge structure, decomposition, and other aspects of the constructive commands were adopted. The general easement curve type is put forward, and the schema of general easement curve is given. The above series of standards will become a part of the IFC 5 standards. And this is our next step. Relying on the pilot projects and engineering practice, continuously improve and verify China Railway BIM standard. Under the framework of BSI, actively carry out IFC rail, IFC common schema, IFC bridge, IFC tunnel, IFC load, and other standard preparation work. This is our suggestion. Accelerate the development of IFC Common Schema project. Lay the foundation for IFC Rail, IFC Road, IFC Bridge, IFC Tunnel, and other standards. We hope that IFC 5 could be released as soon as possible under the organization of BSI. That's all. Thanks.